and we can use both. The occurrence of one does not affect the occurrence of the other. All right. If you have two cars, only one car you can drive at a time. You're driving one car, cannot make the other one drive. It has to be you only, so you drive one car at a time. Okay. Suppose event E is your Ford motor car. So event E is Ford. Let's call it Ford. It doesn't matter the kind. And event F is your Toyota. Let's call it Toyota. So the probability of event E and F is a multiplication. If you say and anytime, it is multiplication. So the probability of E and F is equal to PE multiplied by PF. So in independent events, we multiply. So there are two kinds of independent events also, just like there are two kinds of independent events in addition rule. Addition rule, we had mutually exclusive events and non-mutually exclusive events. In independent events, we can see two events that don't depend on each other. Also, we do have independent events that depend on each other. When we have two events that depend on each other, the dependent events are called conditional probability. Okay, so I think the best thing is for us to go and solve the problem. Go to our practice test and focus on that. But we already know that there are two kinds of independent events. If they are independent and the occurrence of one does not affect the occurrence of the other, PE and F is a multiplication, simple multiplication. But if they are dependent in a way, then it's conditional. And if it's conditional, that's another formula. We're going to write that formula very soon. So if a probability of the two events are supposed to be independent, but one depends on the other, one cannot happen without the other, we say they are conditional. Okay, this is conditional probability. So it is probability of F multiplied by probability of E. I can say probability of F intersection E. And when I say intersection, it's multiplication. Probability of F divided by the second one. The second one is the one that happened last. Whichever one is the one below happens last. So divided by probability of E. So the formula for conditional probability, where F and E are expected to be independent, but actually one depends on the other. There is something you have to do before you do the other. If you're a newborn baby has to, I can say this, but it may not be all right. A newborn baby has to stand before they walk. But miracles do happen now that the baby can just stand up one day and start walking. Anyway, the important thing is that there has to be two of them. And when there are two, we call them compound events. So if there are compound events, PE and PF, and there is an and there, what is the probability of E given, probability of F given E whether it is spoken in English or not, the formula is the probability of F multiplied by probability of E divided by the one that happened last. Okay. All right. So now that we have written this formula, this is the formula for conditional probability. But suppose F and E are independent. They do they don't even, nothing in one concerns the other. They cannot happen together. Then the numerator is the answer. PF multiplied by PV. I hope we all know that intersection means multiplication. Intersection is the same as and, is the same as both. It's a multiplication. Okay, so let's look at the question again here. Suppose that E and F, I'm talking about number 16. Suppose that E and F are two events. Okay, and that the probability of E and F is 0.5. So probability of E and F, that's the numerator, is 0.5. So let me write it on 0.5 in the numerator. Okay, and the probability of E is 0.8, the one in the denominator, this one right here. What is the probability of F given that E happens last? It depends on one. What is the probability of E given F given that E has already happened, whichever one that comes last anywhere? Okay, so all I have to do is simplify, but we have to understand that it is conditional. And how do you know it's conditional? You will be given what is the probability of F given E, and then you get your calculator and find the answer. Let's do that. When you finish solving the problem, your answer must not be more than 1. It's a mathematical fallacy for the probability of an event to be more than 1. Your answer cannot be negative, so you can't get a negative answer. Your answer cannot be more than 1. So let's look for the probability of F and E. The reason why the denominator is there is because there is an intersection. So 0.5 is the probability of both. Both, they have already done it and told us that the probability of both is 0.5. Then I'm going to divide by 0.8. I'm not going to answer. My answer better not be more than 1, better not be negative. Therefore, the probability of F happening, given that E has already happened, is 62.5. You could be told to leave your answer in percent, and you could be told to leave your answer, or you could be told to leave your answer in decimal or fraction. Okay. So I would like to use a practice test to do this because we don't have all the time in the world. So when we do one, they know that we have done it. Okay, so this is number 16. I hope this cannot. Another one is called joint probability because there are some aspects of them that can happen together. The joint probability is called the general OR rule. So anytime you're told to use the general OR rule, it means you are using the joint probability. Okay, we're going to go, I think we're going to finish it there. And on Friday, we'll start answering all those questions you haven't been able to answer. Let's make sure we get to all the probability sections. We already talked about OR and OR are two, mutually and non mutually exclusive. Now today we're talking about and can be independent and they can be conditional. So two of them again. We talked about counting principle, factorial, combination, permutation. Okay, you want to see any of them in a practice test and know how to do it. Okay, so we just did one conditional probability. You will always know when it is not conditional because there is no relationship. The other one does not have any, one happening does not even affect the other. Okay, so we talked about number 16, 17. Let's see if we need to do 17. Let the sample space be that. Suppose the outcome are equally likely. Compute the probability of event E and an odd number less than 8. Okay, well, this probably may not be. So I want to know if there is and there. Compute the probability of event E, an odd number less than 8. So, well, this is not, but we can do it anyway. We can do this one right now. So we, all we're going to do is look at that. Look at that. So an odd number less than 8. So we're going to be looking at them. 1 is an odd number. 3 is an odd number. 5 is an odd number. 7 is an odd number. Okay, and they're all less than 8. Okay, so the definition of that probability is that it has to be an odd number less than 8. Compute the probability of event E. Okay, so that's easy though. That's easy. We are given a sample space and there are 10 of them. The sample space is 10 of them. So the probability of event E from the definition they gave us is the number of counts, number of E over sample space. So I already counted E. There are 4 of them. I hope I'm right. If I'm not, let me know. I hope I did count right. But anyway, I think I did. So the sample space is all of them, 10 of them. Odd number less than 8 accounted for 4 over 10. And then I simplify. I have 2 over 5. I can be told to leave my answer in fraction of or decimal. My answer has to be in decimal is 0.4. 0.4. If my answer has to be in percent, it becomes 40%. So we just have to be careful. What kind of answer are you told to find? Okay, so let's go to number 18. I mean, any question, by the way? Any question? But today we are actually focusing on dependent and independent events. If they are dependent, we say they are conditional. Okay. All right. So I'm going to clear. No, remember that this doesn't clear easily. Okay. Okay. So let's see. 2 events E and F are, let's see, if the occurrence of event E in a probability experiment does not affect the probability of the other. They are independent. 2 events E and F are independent if the occurrence of event E, I hope you know where we are, number 18. If the occurrence of event E in a probability experiment does not affect the other. Okay, we see another question, number 19. Look at another question in number 19. Suppose that E and F are 2 events and that the count N, or the number, the count N, E, and F is equal to 230. They're giving us in numbers this time. The count E and F is, and this is another way of saying intersection. Those who belong to E and those who belong to F are 230, and those who belong to E are 460. How do I know that this is a conditional probability? What is the probability of F given that E has already happened? And by the way, you have to know how to read this. So the question actually told you that it's a conditional probability. How do you know? I'm emphasizing conditional because students find it difficult to. And I try not to put difficult questions in conditional probability because that's a way you put it in, it becomes so. So I try to put in simple questions. But the important thing is you must know the formula, and the formula is not difficult. So just the probability of F given that E has already happened is equal to the probability of F intersection E. I hope you know you can write or there. You can write or, you can write and or both there. So the common probability between them and the one that happened last. I hope you know we don't have to use F and E. We can use A and B. We can use C and D. So the probability of E happening. But this time they did not actually give us probability. So we have to be careful. So they gave us the count. So I'm going to write I'll write it in terms of count now. So the probability, even though they asked me about probability, but they wrote it in count. So now I am going to write the counts of E and F. So I'm trying to answer the question the way I am asked, all over the count of E, because that's how the question is. They didn't go to tell me the probability. They just asked me the number for occurrences or count in E and F is that. All right, so I give it back to them the way they asked me the question. Now I'm going to use what they gave me. So the count for E and F is, the count for E and F is 230, and the count for E is 460. So I'm going to be doing the probability of F. So 230 divided by 460 is the probability of F given that E happened first. All right, so I simplify. Uh-oh, how did I get 8? This is supposed to be 6, I think. All right, so I see that if I divide 46 by 23, I have 1 over 2. So the probability is 1/2 or 50% or 0.5. Okay, so we have seen some questions on probability. We have seen some questions on conditional probability. So these are linear regression. So we will come back and get to linear regression. But Friday, we start going back to linear regression. Uh-oh, is that all? That's not, there should be multiplication rule there. Anyway, okay, well, let's get one. Let's make one up. Suppose this is question number 21. Given that events A and B are independent. Event A has a count of maybe Or I just say event A has a count of, might just put it 0.5, and event B is event B, EB, is equal to 0.2. Find the probability of event E. Is it E or A? I'm talking about A and B. Find the probability of A and B. Don't forget that intersection means and. So all I have to do is probability of A and B is probability of 0.5, or I can just say probability of A multiplied by probability of B. They are independent, and there is no way, I haven't been told that they are conditional. They are independent and they are not conditional. So I'll multiply their by getting the answer. So 0.5 multiplied by 0.2. What was that I wrote there? Well, let's say it is 0.2. 0.5 multiplied by 0.2 is 0.1. Therefore, the probability of A and B happening at the same time is 10%, 0.1. The probability of A and B, note that this is an independent event. Independent event, the happening of one does not affect the happening of the other. So I just do a simple multiplication. It can actually be more than two events. It can actually be more than two events. Suppose I say that suppose I'm given the probability of E is equal to 0.1, probability of F is equal to 0.2, and the probability of A somewhere, let me say A, is equal to 0.3. And I'm told that all these events are independent. They happen on their own. They're independent. It doesn't even matter if they are 10. Therefore, find the probability of all of them happening at the same time. Because they're independent, it doesn't really matter. So it's going to be PE multiplied by PF multiplied by PA. Why? Because they are independent. None happening of any of them does not concern the other. They are not conditional. So all I have to do is multiply all of them. One, somebody actually made a name out of it, but you're not going to call it. You may read a book and say it. Somebody does a theorem concerning this, but we're not going to ask you about the theorem. Anyway, when you finish multiplying, the result is the probability of the compound events. The compound because there are many. There could be 5 of them. There could be 10 of them. Important thing is that they are independent. In other words, happening of one does not affect the happening of the other. So they are solely independent. And is and, so we are multiplying them. The important thing you want to take away from it is that when two events are independent and happening of one does not affect the happening of the other, it is an and probability. And an and probability is a multiplication, ordinary multiplication. But if two events are independent, and what actually you find out that one is dependent on the other, one has to happen before the other, then it's conditional. The dependence is conditional. And so you use the conditional formula. So we found out 2 days ago that the all probability has two of them. One of them is joint, not mutually exclusive. The other one is joint. Okay, you can call them disjoint, joint and disjoint. Okay, so all probability has 2 of them, and probability has 2 of them also. So it could be independent, happening of one does not affect the happening of the other. It could be independent but conditional. And you need to know when it's conditional. And actually, the question tells you when it's conditional, though. One has, if you tell that one has to happen before the other, then it's conditional. Okay. All right. So let's see if we're going to, there's actually no other. I think there's not a lot of question in that practice test. And that's not